Good morning, everyone. Let's get this stream up and running. Okay, seems like it's up and running. Welcome, everyone, to my stream where I am recreating a simple game called Suika Game. It's a game where you drop fruit on top of each other, and if two fruits of the same type uh, touch each other, they combine and create a bigger fruit. And once you get to the biggest fruit, which is a watermelon, it disappears to clear out space for more fruit that you can drop. And so this is what it looks like. And this is what I'm gonna be trying to create. So let me open up the files and show you where I am so far. Where I've gotten. So these are the two JavaScript files that I've been messing with. All right. So this is what I have so far. I'm able to render circles for one with textures on top of the circle. I'm able to render multiple objects. And finally, I'm able to drop um, or add more objects to this. I'm not sure where it went, so I'm gonna, yeah, there we go. Yeah, I dropped it off screen just now. So yeah, I just added a grape. Let's add a lime. Lime looks different. Yeah. Oh, and I'm also able to rotate the object instead of rotating the screen previously. So yeah, that's where we're at. Now let's open up my README file where I have a list of to-dos, things that I've been thinking of doing. And let's see. Okay, so basically I think we're good at this point. Well, so maybe let's do one last WebGL thing. Let's add in a box container. And the box container is going to be this box that I want to add in. So it's interesting because this box looks 3D, but the game actually is 2D and everything is just flat against the front of the box. I think that's pretty interesting. So then the question for me is, do I want to create a 3D box or draw a 2D image that looks like a 3D box? I'm gonna go with a 3D box. And then the top is empty. Yeah, I think a 3D box that's like a little is translucent. That'd be something interesting to try to implement. All right. So we do have a box, so we know how to create a box. So that's good because that means that we only have to tweak it. Hmm. Cube, box, put the box all the way back. Box, texture. Let's make it a box texture. So actually, the box does not need a texture, right? 0, 0, -6. Sure. All right, box. In the draw scene function, I that's where I'm drawing the cubes or circles depending on whatever I have. That's in the draw scene function. So I have a separate sections depending on whether it's a cube or whether it's a circle. So now I can add an extra section for when it's a box because the box is going to be a little different than a cube. And this box is only going to be, yeah, and actually, while I'm at it, let me move this cube a little bit out of the way. So minus, let's see, 0.1 minus, um, let's see, let's move it off to the corner also. Yeah, there we go. Put that cube over there. Okay, so program infos, box. So I'm gonna create a new program info as well. That would be the vertex shader and the fragment shader. Mhm. So let's rename that VS box and then FS box. So the different shaders and then gonna also init the shader program, box shader program. So that's one of the things about being a software developer is that it's really kind of like same song, different different verse, something like that, where it's really minor changes to a code that that works, making tweaks to it. So I do not need the texture chord because it's all gonna be the same color. Yeah, so I'm gonna refer back to the tutorial way back in my first streams where yeah, so one of the first things um that the tutorial covered was creating a colored box. So yeah, so geofrag color vec4. So that just creates a white box. Let's scroll all the way down to the bottom. Yeah, white box. Um, and then the next one was applying color. So let's see how that one changes. Okay, so okay, vertex color, V color, and then frag color is also V color. So let's see what that means for this. So we have the vertex position. We have a vertex position, and we have a vertex normal. Vertex color, VS color. So now the question I have is, should I hard code it or should I have it as a input parameter? Let's go with the example for now. Model view matrix, projection matrix, and then out, out. Well, low P for the geo position, V lighting. We have V lighting. Add a V color. And then the fragment shader is gonna consume this V color. Um, so we have the V lighting from a future tutorial. Add a V color. And then let's see here. Okay, so we won't need the sample there 2D, which is used for the it's used for texture. Instead, we will just do the here we go. So RGB, that's actually the V color. Um, yeah. Okay, cool. So it's splitting this into so the V color has four components, RGB and A. RGB is the color part and A is the opacity. And then so we multiply the color component with the lighting to give it the shade of light. So I think this should work. Let's go back a little bit, make sure everything lines up. Okay, V color. So that's a vector of four component. Yeah. So see here, it's hard coding the lighting. So I'm wondering if I should do the same thing with the actual color of the box, but we'll just um, pass it in for now. Gives it more flexibility. Okay, so we got the program infos that we also need to make a box program info for. That contains the shader program we just did. and these are handles to certain things inside. So inside the shaders. Yeah, so we had the position chord. We need to pass in a pass in the color as well. Projection, view, yes, yes. Rotation, not needed. Sampler, not needed. Yeah. So let's go back up, to see whether we're using the rotation. Yeah, view model rotation, not needed. View model rotation matrix. Mhm. Okay. Hmm. So we have the normal matrix, model view matrix, projection. View normal matrix. Let's check this. Vertex normal. A vertex normal. Okay. Oh wait. A vertex normal. A vertex normal. A vertex normal. Let's see, where's that used? U normal matrix. Hmm. Okay, A vertex normal. Transform normal. So maybe we do need the A vertex normal. So vertex position, vertex normal, vertex chord. Yeah, let's add back the vertex normal. Um, box shader. And then projection matrix, model view matrix. We probably also need projection matrix, the normal matrix. View normal. Yeah. So you normal. So all these variables, the A vertex position, A normal vertex normal, A texture chord. Actually, we don't need this texture chord. But U projection matrix, U model view matrix, U normal matrix, these are all things that should also be corresponding, be defined in the shaders. So we have 3 and 3. So yeah, so let's see. Vec4, A vertex color. So I think we had the chord, texture chord. We don't need. Instead, we need the vertex color, texture chord. Yeah. So A texture chord. Instead, we need the vertex color instead. Okay, I think that captures it all. So one thing I'm thinking about right now is the buffers. The buffers might need to change as well. But let's just continue with what we've copy and pasted, making the adjustments for that for now. So rotation, we're not going to be rotating the container box. Scale, Should we? Let's just leave it in for now. Nah, never mind. Normal matrix, yes, we need that. Invert, transpose, set position attribute. Okay, so these are gonna be different. Box position attribute, box normal attribute, box. Instead of texture, we're gonna do color. Box color attribute. And then we're gonna have to define all these methods or copy and paste and adjust them rather. Bind buffer. So let me check the tutorial, see if this used to be something else. Okay. So yeah, so this is the set color attribute. It's a little different. But yeah, let's see. Next, draw scene, which is this. All right. Maybe that will be fine. This will be fine. Buffer is indices. Projection. Yeah, don't need the rotation. Don't need the texture. Mhm. Let's see. 36 vertices. This might change because whereas the cube has 6 faces, the box has how many faces? 5, because the top is empty. So this might go down to 36. From 36, it might go down to 30. And this is 36 because each face is actually 6 vertices because there are 2 triangles. So let me draw that out. So each face looks like, and a box seem like 3, 4. But actually in WebGL, each face is actually 2 times, and each triangle is so 1, 2, 3, 4, 5, 6, something like that. I mean, I'm numbering them not in the correct order, but that's the explanation of why there's 36 vertices for 6 faces. Okay, so yeah, let me take a peek at the draw scene function, see if there's anything I missed. Draw scene. Okay. Perspective. Translate. Position attribute. Okay. Yeah, so it doesn't seem so. Doesn't seem like I missed anything. So, okay, so let's just go ahead. So I'm gonna just first render the square or the box, as a cube with 6 faces. And then if that works correctly, then I'll move on to um, don't need use sampler. Then I'll move on to removing the top face and seeing if that works. Okay. Invert, transpose, box position. Okay, position, normal, color. Let's define those functions. Yeah, so set position, gonna need a set box position. Set box position. Bind buffer, buffers dot position. So where are my buffers defined? Let's take a look at the positions. See, position buffer. Yeah, position buffer is init position buffer. Let's take a look what init position buffer is doing. Init position buffer. So these are the 6 faces, and the XYZ coordinates for, or actually not the XYZ, just the XY, or are they the XYZ? Yeah, they probably are the XYZ coordinates. Twelve. Mm, normal. So these might also change for the box in the position. So we're gonna also change the change the or add buffers for the boxes. We're not gonna reuse the cube one. Normal box, normal buffer, index. Index should be fine. Or no, we'll need we'll need to redefine this as well because we're gonna be removing a face. Hmm. Okay, so we uh we've we now have new functions for the index, normal, index, normal, index. Yeah, let me check. Box index. Yes, index, normal, index, normal position, index, normal position, position, box position. So we can reuse the color buffer because the cube is not using the color buffer. position, position index normal. Position index normal. My position index normal. Yes. Okay. So those look good. Mm, hmm Add on to it. Box position, box normal, box indices, box position, box normal, box index. Okay. So yeah, these are gonna be so the color buffer is yeah, it's different color for each face. In uh the end they're all I'm gonna redefine them to be one color. Yeah. So init texture buffer. Okay. So we've redefined the buffers. Now let's use them in the draw scene function. And that will be inside of, well, let's first see. Okay, so instead of this, it's this. Yeah, let's do a once over. Make sure we put in the right, we change the right variables for box. Okay. So now set box position, set box normal, set box color. So the only thing is I don't need, I can reuse the set color attribute, but position and normal, let's do that. Set position, set circle position, set box position. Yes. Um, okay, attribute vertex position. Okay, so yeah, here we are. Box position. Set box position, set box normal. Yeah, set box normal. Box normal. And then color is fine. Okay. Let's give it a go. All right. It should have an error. Yes. Okay. Of undefined attribute locations. Okay. 384 modules. 384. 384. Okay. So I'm guessing it's up here. Object program infos dot box. Most likely I don't have that defined. Program infos. I never added that, if I remember correctly. So under game, we got box shader program, program info. We got a box program info, but we've never added it here. Okay. Okay. So so the floating box, we move that down there, so it's out of the way. But we got some errors we need to address. Location is not from the current program. Okay, great. 248 in modules. Then draw a scene. Probably missed the variable in here. 242, 248. Okay, normal matrix. Um, normal matrix. Program info dot uniform locations dot normal matrix. Let's take a look. Box normal. Okay, hold on. Let's see. Normal matrix. Maybe I missed it in the setting the attribute. Box normal attribute. Vertex normal. Box normal. Okay, box normal is fine. Hmm. Box normal buffer. Yes, that's fine. Position. Position normal. Box normal. Hmm. All right. Let's look at this. See if we missed something here. Box program info. Yes, we did. Shader program. All right. Okay, draw elements. No buffer is bound to enable. 254 inside of modules. Making progress. Still in the draw scene function, we got an error. 254. Okay, so draw elements. Let's see. No buffer is bound to enable attribute. Let's see. So what did I mistakenly delete that needed to be here? Okay. Model view matrix? No. Model rotation matrix, perhaps? Find buffer, use buffer, buffer dot indices, box indices, use program. Projection, model view, normal. Projection, model view, normal. So those are the three that I need in this one. Projection, model view, normal. Okay, so I didn't miss any. Only question for me is the texture. No texture. Hmm. No buffer is bound to enabled attribute. 254, 226. 226. Okay. Let's see. Let's see if I missed anything. Box scale. Box offset scale. So this is the cube shaders. These are the circle shaders. And this is the box shaders. Okay. A vertex color. Okay. Maybe it's because I haven't defined any vertex color going in. A vertex color should be that. Let's see. I think the issue is that for my colors, I have defined as uh yeah, so for my colors, I have them defined for each vertex. Um, let's simplify things. So not gonna pass in this vertex color. Instead, I'm gonna do what this is doing here. Hi vec4 color. So let's define the box to be maybe more pinkish. Yeah, more pinkish. Well, this is maybe a very dark box. Yeah. So this is gonna be a very light pink, a very transparent box. V color. Let's just yeah, yeah. There we go. Vec4. Vec4 color. V color. Okay. Hmm. Yeah. Okay. And then let's remove the references to the color. So in the program info, we won't need the color no more. In the draw scene, box. Not gonna need to set the color attribute. Okay, let's test it out. Okay, so we have something. We have something. We have a square. But it doesn't look very transparent. Well, maybe it is transparent. Yeah. So one thing I'm thinking is that the each of the faces, their normals are pointing out. But for the inside faces, or for all the faces besides the front, we want them to be pointing in because we're looking into the box. So let me try to change the normals for that. See if that'll make things look different. So box normal buffer. So this seems to be the top face because it's Z1, or it's the normals are pointing up, directly up. So so let's make this pointing down. So the top face is pointing down. The bottom face is pointing down. Let's invert that so it's pointing up. Okay. See X Y. Oh, hold on. I I got my axes mixed up. Well, hold on. So Z is the axis that's coming directly out of the screen, and 1 is pointing at the viewer. So this face is actually the face that we're looking at, which should continue to point out at us. And then the second face is the face that we're is the back of the box, and it should also be pointing out at us. The third face, X, Y, Y, this one is pointing up, and this is the face that we're gonna eventually get rid of. But now we're making it point down, and then this is the face on the bottom, make it point up. Now this X1, so it's pointing right. That's probably the face on the right. Let's make it point left. And then the face on the left, let's make it point right. Let's see if this has any effect. Doesn't seem to have any effect. The other thing is, so we encountered last time with the shade, like with transparent boxes, we need to blend them. Let me look up where that's done. Make sure that it's being okay. It's done at the very top, so it applies to everything. Okay, let's see here. It's going back to the shaders to look at them, stare at them some more, see if I spot anything. XYZ. So this does not need to be high P actually. Low P will do. Oh, wait a minute. I wonder if I should define it as um, as RGB values. Yeah, let's take a look at the color buffer. Okay, and so no, it's oh wait, concat. Wait, okay. Hmm. Uh, okay, color buffer. Try this. Okay, so no, it doesn't take int arguments. It takes what I had earlier. Hmm. Just tuning the colors. Okay, that looks more reddish. Mm, ambient light, directional vector. So for the direction, let me change it also to light is coming from the viewer directly to the box. So this should either be 1.0 or 0 or negative 1.0. Okay. Um hmm. So no matter how I look at it, it doesn't look yeah, it doesn't look transparent, which probably that's obvious. E color, E lighting, E color, RGB, A. Box. So wondering now whether it's because we're um showing this first. Maybe we need to put it as the last one instead. Okay, getting somewhere. Hmm, interesting. Yeah, so that was that. So that's the ordering. Ordering matters. Everything needs to be rendered before this because when this renders, it will only take in what's behind it, and what's behind it needs to already have been rendered. Um, so now I'm wondering, hmm, if it's like this, then it means something. So I mean, I don't see so I only see this front face. I don't see any of the lines or differences. Well, hold on. That might be because it's all the same. Like, okay, let me draw out what I'm visualizing. So see what I'm thinking that we kind of like this. Then this should be the dark color, and then this should be a bit light. But so what I neglected to realize is that what I'm looking at right now is this. So everything inside of the front face is covered by one and only one other face. So I'm looking at everything that's two faces, if that makes any sense. So if this theory is correct, if I were to remove this top, then now this will look a different color. So let's check out the theory. Save changes. Don't save. Hmm. And that's why we define the buffers. We separated out the box buffers so that now I can remove the faces. So init position buffer box. Okay, box. Right. So let's go look at the normals because it's clearer to see what's going on. So I think it's the third face that needs to be removed. Normals X Y. Y is the vertical axis, and if it's pointing up, yeah, third one. Okay, but let's do it to the right uh, function. So the third face needs to be removed. Box positions, third one. Mhm. So we've done it to the box. Sorry, the position, the normal. Also need to do it to the index. Index, third set. Uh, Not sure actually. Yeah, I'm not sure about that. I'm just gonna remove the last one because index might be the indices of the arrays. So if I removed one row of six, then it's not gonna matter. It's or yeah, so it's the index of the array. Okay, box. Now it's down to 30. See if this works. So there's no errors, which is good, but there's also no difference, which is bad. Hmm. Position index normal. Position index normal. I'm gonna move or make this not a cube, so make it a longer rectangle. I'm gonna just double the y's. Ah no, wrong one. All right. Okay. Hmm. So it's missing the top face. Hmm. Missing the top face. Hmm. Yeah. Let's ask Google. WebGL render transparent Parent box. Okay, depth test. Depth test. Is that what's going on? Alright, so draw scene. The depth test might be the problem. Wow, we have it. Nice. Nice. Very nice, actually. Cool. Interesting that it's blocked view. So yeah, interesting that an artifact here. Hmm, interesting. So let me check out the blend function, see if there's, yeah, see what are all the options and what this one means. 1 minus multiplies all colors. So currently what I have is one function source alpha, 1 minus source alpha, 1 minus source alpha, 1 minus source alpha. It multiplies all colors by 1 minus the source alpha's value. What's S factor? A multiplier for the source blending factors. So source factor and destination factor, those are the two parameters. So source color, colors by the source colors, destination color, destination color. Hmm. Just playing around with these. Hmm. Interesting. Oh, I think box got nothing going on. It's not rotating. And so everything in here stays frozen. But what I'm wondering about is how come these dots there's just no dots here. Hmm. Let's revert. 1 minus source alpha. Let's see what they have here. Looks pretty good. Use transparency. Set transparency. Clear color. Depth test. Equal depth mask. False. Enable GL blend. Yeah, so they use source alpha, source 1 minus source alpha as well. Hmm. So yeah, it's interesting to me that the back face. So the dots are making it all the way to the front face, but not the back. Hmm. Is there any way to address this? Let's take a look. Box normal. Yeah, box normal. Pointing straight out at me. What if I change it back? Well, that's interesting. So this does look like a box. And maybe I was wrong. I was wrong. Um, about the normals having to be oriented in a certain way. So let me change them all back. Uh, yeah. So I've changed the first 2 rows back already. Let me change the last 3. Okay. Now I want to add a border. Otherwise, it looks a little. Hmm. Or maybe change the lighting. Yeah, maybe change the lighting. That might be more easier to do. Shader. Let me take a look at what's going on in this box back here. Oh, that's interesting. Yeah. So see directional. Um, X. How about from above? So it'll be this is gonna be above, directly above. How about also to the right a bit? Let's see if this does the trick. Okay. Yeah. Hmm. All right. Um, how about let's make these two not the same. Top right corner currently. Yeah, it's um doesn't replace, having more clearly defined. Yeah, doesn't replace having more clearly defined. Yeah, more clearly defined um borders. Hmm. Let's ask WebGL. Um, Texture coordinates. Hmm. Okay. Cool. Uh, I think I know what this approach is. I need to figure out a way to pass in the dimensions of the box, and then in my shader, so pixel shader, that would be the fragment shader. Um, I need to test if my coordinate is one of the bounds, then color the pixel a different color. Let me see. Okay. The alpha to 0. Solid border. Hmm. Let's try this. Lines inside of draw scene. And I'm gonna need to use the position. Yes, position. XYZ, 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 XYZ. Draw scene, box, draw element. Um, Vertex indices buffer, num items. Might not work, but let's give it a shot. Okay, gotcha. Yeah. So it's drawing them. But yeah, it's drawing them. Like it's drawing the triangles. Hmm. Box. Yeah, I think this is the reason. Yeah, so this is an alternative approach. Line width. So let's get rid of this. Okay. So let's go back to the first approach. The only thing is that I need to figure out how to add in the coordinates. Oh, alternatively, let's see. So if I know I'm at the border, um, one is at least one of the other values is going to be 0. Um, maybe let's try that. See where that gets us. V texture chord. VS box. So I'm still getting a V texture or outputting a V texture chord, which I don't actually need. Okay. Do not need a V texture chord. Color, directional, normalize, normal, transform, V color. Yeah, I'm thinking maybe I should set the color here. Wait a minute. Do I do anything? Yes, V lighting, V color. V lighting, V color. V lighting. V lighting. V color. Yeah, change this color to something different. Um, hmm. View normal matrix. Transform X, Y, Z. Transform normal. Position. Transform normal, vec4, which is the same as this A vertex position. Then set the color to 4. Yeah, solid black. Try this. Okay. Right. So I should have looked it up. WebGL shader language. Let's see what supported. Data types, variables, operators, logical. Okay. Float. Assignment, logical division, bitwise operation, if. Um, if. Okay. Huh. So it does, um, it does, uh, hmm, fragment shader. So I'm in the vertex shader. If if enable equal 1. Um, let's try without the other conditional. Parameter 2. Wrong operand types. No operation that takes a left-hand operand of float and a constant int. Okay, well, this wasn't as big of a deal as I thought it was. So it didn't do anything. So does that mean this position is never 0.0? Like 4. Um, less than or equal 0.1. Let's make the lines thicker. Ooh, oh. Hmm, hmm, no, making it a gradient. Yeah, abandon. Abandon. No, it is interesting that it's showing. Alternatively, yeah, let's look into alternatives. Alternatively, so I'm just defining this like so. Alternatively, let's just set the colors. So face colors, right? Let's see. So I got rid of the third face. Um, so none of these apply anymore. Let's see. So maybe make them all same transparency. Okay. Now, then. Let's see. So for the box, what's the first face? First face is pointing towards me. Second face is the back. Yeah. The first face is the front face. Second face is the back face. Let's make the front face. Let's make the back face the most red. Front face. Sorry, 0.5. Next is the bottom, I'm assuming. So the third one is -2, -2, -2, -2. Yes, it's pointing down. So it's the bottom face. Bottom face followed by the two sides. Yeah, bottom and then two sides. So let's make the bottom, bottom, bottom. The bottom should be black? No, no. Um, two sides. Do 0.6. Okay. So we have the color buffer, and the color buffer. Okay, box color. Draw scene. Set box normal attribute, set color attribute. That should do it. Okay. Double check the color attribute for the color buffers dot color box color. Okay. Now let's implement it in the shader. Refer back to the tutorial. Just to make sure we don't miss anything. Apply color. And the color buffer. Back 4. 3D objects. Positions. Face colors. Index. Bind. Buffer. Bound to the indices. Cube rotation. Draw scene. Okay. Animating. Oh. Yes, source. Okay. VS box. Position. Okay. And then low P vec4 V color. GL position. Don't need this. V color is a vertex color. Fragment. V color. V color. Okay. Using colors. Shader program. Box program info. We now need a vertex color. Set color attribute. Vertex color. Yeah. So set color attribute. Vertex color. Buffers dot color. Wrong one. Box color. Vertex color. Okay, yeah. So this is correct. All right. Try it out. Cool. Awesome. Seems to be working. We got our box defined. Let's make a little tweak to the bottom face so it doesn't look like it's empty like the top face. Let's see here. Colors. Yeah, so the top face seems to be, the back face. Maybe make this a bit lighter. So let's change that, change it with, switch it with the one on the bottom, like so. One on the bottom. Oh, wow, okay. Hmm. So when it's opaque, yeah, yeah. So this is interesting. So what I had thought before is correct, where the normals do matter. So let me demonstrate by, so this is the third face, which is the bottom one. Um, Let me revert or invert the coordinate for that one. So it should be pointing up. There we go. Yeah. Yes. Let's adjust the lighting as well. VS box lighting. Hmm. Let me see what this does. That's interesting. Hmm. Maybe this is better. Hmm. Yeah. Let me tune down the front face. Uh, Very red, but let's make it very transparent. Hmm. Hmm. No, I didn't like. So something interesting happened. It leads me to believe that the top face actually is solid and it's the bottom that is emptied out. Um, So I'm gonna test this with the position. Um, y, y. Oh, the third box position. Y. I'm gonna change this. So now it's reversed. Okay. Normal. Colors. Wanna make this directional, shining from above, down, shining from above, shining down from. Yeah. So this is why it makes me interested that that it would change to such a degree. One, you know, like so this is basically we have a light from up top shining down and it's hitting this and reflecting. Let's try making the color this face transparent, totally transparent, so we can see what's going on behind. Ah, wait, what did I do? No, I made it totally opaque. 0.0. Okay, yes, so it was as I expected. Yeah. Um, maybe not bright. Maybe not bright. Yeah, bright red. Okay, I think that's good. Yes, sirree. Add this back. So we got a nice little box to start dropping fruit into. So yeah, this took a little bit more work than I was thinking, but glad that we got to a good result. you know, and we'll pick this up next time. Cool. All right. Let's see. Any comments? No comments. Great. Thank you all for watching. I will see you all next time.